Hi there, Internet. Today we're going to be working with fractals. Specifically, we're going to be working with a fractal tree. So, we kind of got started a little bit already. We've got two little branches, I guess, we're going to start with. And the idea is we're going to kind of divide these up and multiply them and come up with some fun scripts to spread them out and create some tree-like structures based on a pattern. If you're not familiar with fractals, it's a mathematical equation or whatever. And say whatever, it is a mathematical equation. But the idea is you can apply it recursively and get some sort of pattern out of it. So a lot of people have seen like Sierpinski's triangle, is what it's called. It's just a triangle, and then you divide that into three triangles, and then you divide each of those triangles into three more triangles, and so forth. And you get triangles and triangles and triangles. Triangles all the way down. We're going to do that in reverse. We're going to make branches all the way up. So, at least that's the plan. Don't know if it's going to work. Never done this before, but I have a plan. So, I've kind of gotten started a little bit. Like I said, we have two branches. And I also have this guy here. Doesn't do anything, but I have him. And yeah, I think that's it. So, we'll jump in here, and the first thing we want to do is state the number of times we're going to multiply our fractal thing. So to do that, I'm going to set a public integer of the number of times to recurse. Made that all like grand buildup and create a number. Cool. I'm going to set the default to 5 because I like 5. Don't judge me. So we've got 5. Now, the idea here is we're going to duplicate our component, the exact one we have, and then we're going to decrement this. And we're going to do that until this becomes 5. So, assuming I did this right, I can write that loop in here in our object start. And then we should just get 5 of each of these. At least that's the plan. So first things, let's subtract from our recurse value. So we'll just count down. And then we will instantiate a copy of this guy. And so this is going to return a copy. So I want to take this as a game object. By default, oh, I was wrong. Instantiate returns a game object by default. That's because I'm passing it a game object. I knew that. Okay, well, ignore that. So we have our copy of our object now. And what we can do is we can grab this. We want to grab our recursive instantiator. I don't really like that name. Even when I come up with it off on my own time, I don't like my names. Recursive, that's going to be just a copy, and we're going to get the component from that. And we're going to get the recursive instantiator, that guy. And then all we need to do is subtract 1 from its recurse value. So, assuming I did this right, we're going to need this in an if, otherwise I'm going to crash my computer and probably break my recording, but we'll pretend like that's not happening. If recurse is greater than or equal to 0. Yeah, I think that's it. So I already have copies of this script on both of these objects. So assuming I did everything right, this should just work. And it appears to have, we have 4 copies, it looks like. Yes, 4. And I'm guessing that's because we subtracted from it initially. Yeah. So we're subtracting 1. So this one, the first one's going to be 4, then 3, 2, 1, and then 0. Which makes me think that there should be, I'm subtracting twice, because we're doing this recurse minus equals 1, and then I was doing it again there. I don't actually think we need that. I think if I just do this, it should work. That looks better. So 1, 2, 3, 4, 5, 6, 7. I would have been okay with 6. I would have been okay with being off by 1, but I don't know why I'm off by 2. I think it's because 5, 4, 3, 2, 1, 0 is 6, and I'm doing the -1 outside here. So I'm going to bring this in, and then I'm going to remove this equal to. So it's going to copy for 5, 4, 3, 2, and 1 when recurse is equal to those values, but as soon as it hits 0, it's going to stop. So that should fix it, and now we should get 10 objects. This was supposed to be the easy part. I'm kind of worried now. Okay, so we do have 10, so we're good. We've got our cloning objects. Next, the plan is to use message passing. So we're going to kind of play around with components here. And the way Unity does this is it allows you to send messages between your components. This is kind of weird in a C#-like language. I don't think this is something that most other projects let you do, but Unity lets you, so we're going to take advantage of it. And what it does is there's a send message here. And what this is more or less saying is invoke this message on a component in your object. So there's a send message upwards and a send message. Send message upwards, I presume, means call it on every ancestor of the behavior. Okay. And send message is just going to call on this specific game object. So that's the one we want. We only want to call here. And I'm going to just say generated. That is a really bad name, but we're going to go with it. So we've got this generated guy here, and that's going to get invoked. And so what we need is we need something to catch it. And so I'm going to create another component here, and I'm just going to call it the grower. Yeah, the names are getting worse. Grower. Sure, we'll go with that. I'll fix it later. I say that. This is going to never change. But anyway, so what we need to do is we need to take... Ooh, it's fixing my line endings. We want to take our generator and do public void, and it should just be this. I haven't done these in a while. I'm kind of on the fence on whether I like them or not, but this should just work. It's going to call a method in all the components with this name, and if you pass it a parameter, which we may be doing later, it will fill that in as the parameters. I think that's what happens. So what we're going to do is we're going to transform the object up. So I'm just going to add the up vector to its position. And since all of these are 1 unit tall, this should just make it 5 units tall. Or it will get a bunch of exceptions because I did not add this to it. So it looks like you get an exception if you do not have something to receive the event. That is good knowledge. That's something we want to know. And that is broken. Interesting. I wonder why it went up only once. That gets even more interesting because the only one that didn't go up is the last one. Oh, I know what we're doing wrong. So we want to recurse on this one. We want to send the message on the new one we created, not on the current one. Because if we're doing it on the current one, then it's going to think that it was the one that split, and that's not what we want. This should fix it. There we go. So if I go into here, you can see we've got 5 units tall. I kind of did the spheres so you can count them more easily. But we've got both of these, they're 5 tall. So that appears to be working. We can grow our tree thing. Yeah, we're gonna go with tree thing. So next, I think what I want to do is I want to add a loop here. And we're gonna do the split number. By default, I think I'll have that as 2. And so what we want to do is we want to loop here over I is less than the split number. And so what this is going to let us do is it's going to let us copy this object multiple times, which right now seems like a big waste of time and is going to be super slow. Let's just make this super slow. Yeah, make a ton of objects. But the cool thing with this is that now we have 2, and then 4, and then 8, and then 16, and then 32 of our object. And so we can kind of, if we start angling them with another component, we can actually start building this thing. So to do that, get component, we want to send a message, and we want to pass in I believe that's what we want. And so this is going to take an int of the index. And I'm just going to make sure this works. We know that it'll throw an exception if it can't find a message that fits. And it did, because our tree grew. So that's good. Our message is still getting through, and it theoretically is passing our index in. We're going to find out pretty quickly if that worked or not. So now that we can kind of grow things, I'm going to add another one to do something. Let's see, based on the index, we want to split things. And so we do that by rotation. Okay, that can't be the name. It's going to be the name. Sure, the rotation class. That's helpful. I'm just gonna copy from here and then paste. And then what we want to do is we want to transform our object by Euler 30. Yep. So that didn't make any sense. So what we're trying to do here, what we're trying to do here is we're trying to take our rotation and rotate it by 30 degrees on the x-axis, which should be this way. Yeah. So that's the idea. Pretty sure this isn't going to work, and even if it does, it's all going to rotate at once. But we're going to try it anyway. So to do this, just plop it on here. It will be called automatically by our event. So what did we do? We broke something, but it looks awesome. Kind of. I don't. Okay, so what appears to be happening is the origin is down here, down at our 0, 0 point. And so the origin is always staying there, but it's rotating everything else as it's going. And that's why we're getting this weird shape, because the origin is at the bottom. And so it looks like the issue is that we're moving up, but we're not moving up in the local direction. And so we can fix that by changing this to be the transforms up direction. So now it should grow up based on its parent, like this. So now we have some tilting things. Cool. It's sort of a thing. Problem is, there's still 2 of these. I can take this one and delete it. Well, I can take this whole guy and delete it. Sorry. I had already deleted the other one. That's why that happened. But I can take it and delete it, and it's still there. And so forth. This one has a lot of them. We don't want that. What we do want, though, since we have this index, is we can actually take that and multiply it out. So to do that, let's take the index and multiply it by 2. So the index is either going to be 0 or 1. And so if it's 0, we're still going to get 0. But if it's 2, we're going to get 2, because 1 times 2 is 2. Then what we can do is we can subtract 1 from that. So this way we'll either get -1 or we'll get 1. And so this way we'll either get -30 or 30, because we're multiplying the 2. So assuming everything works correctly, we should get something that looks a little bit tree-y. It does. Awesome. So now I'm going to disable one of these because 2 of them is confusing. We'll get rid of this one, the robot cube. I don't know why I called it that. And then I'm going to try to rotate it so it actually faces the camera this time. Run this again. And we get our tree. Cool, huh? So this is, yeah, that's what we need. But we can make it a little bit more interesting, right? Because there's more to it than that. We want to let's cut the branches in half every single time we do this. And so as we grow our tree, the branches will get smaller and smaller and smaller. And then it will just, yeah, it'll look nicer. And if you look at what other people have done with fractal trees, you can Google it. I may even throw an image in. But if you look at what other people have done with it, they're cutting their size of each of their lengths in half every single time they do that. So the first one will be half the length. The next one will be a fourth of the original length. The next one will be an eighth, and so forth. And so that way it kind of keeps it all together. Because if I keep adding nodes here, we're going to really quickly get off the screen. And I don't want to do that. I want it to be all cool and right next to me. So we're going to, well, we already have one called rotation. Let's call it scale. So this is going to need to copy this guy again. Cool. So we've got our generated. And we can take the rotation, or the scale actually, and multiply that by a new vector 3 that is 1/2. So that's not how you do that. We want the local scale. There is no such thing as scale in Unity. Times equal cannot multiply that. Right, you can't multiply a vector by a vector. That doesn't make any sense. But you can multiply a vector by a float. So that's what we're going to do instead. Yeah. So now we have our scale. Let's plop that in there. And each time we do this now, it should shrink. It's going to look really weird. And that's because we're still growing by 1 unit each time. And so every single time we grow by a unit, it isn't necessarily a unit anymore because we scaled everything. So let's go into here, and we can actually multiply this by the transforms local scale dot y. So if we multiply it by the y scale of the object, everything should line up again. And it does. Cool. And now everything is super tiny. That's less cool. I think what we want to do is it doesn't really matter how much we scale it by. So let's take a scalar float. We can still default it to the same thing, but if we do that, and actually, let's plug in some other stuff too. So degree angle. Let's call it angle. That makes sense. That actually sounds like I thought this through. So we'll plug in the angle there. And now we have our angle, we have our scale. And now I can actually change these. So I can actually make this whatever I want. I can make this a third, 2/3, sorry. And yeah, we'll get to the rotation later. Don't know if that's gonna actually work or not. Cool, so yeah, we got our scaling stuff. Let's add 10 recursions. Oh, this is a bad idea. It's starting to look cool though. I mean, let's zoom in a bit. But that's pretty cool. And we did that in 22 minutes. That's not bad. It's not bad. So this is a fractal. We're repeating the same thing, the exact same thing, over and over and over again, and we're getting these really cool patterns. But the fun thing is we can change this. So I can switch back here, throw my scale on him, enable that, and do, oh, that's wrong. Flip him so it faces the right way. So now we've got this guy sitting there, and we can do the exact same thing. 0.666. I didn't mean to do just 6, but oh well. There. But now we can do whatever. This one just has a ball on it. So now it's got some weird shapes that are different than the last one. And I can make ball jokes now. But yeah, this is that. This is it. Cool thing here is we can just keep going with this. We can change whatever we want. I can add more rotations. I can make this curve in 3D. Can do whatever we feel like. And that's kind of, I don't know, that's kind of the nice thing about this message passing thing, is that I can create a message and just subscribe to it. And then anything that needs it can use it, and anything that doesn't need it, oh well. That's sort of the power of it, but I don't know. This project is up on GitHub, so if you guys want to play around with it and make something really cool, yeah, go for it. I'd be really interested to see it. So yeah, till next time, see you, Internet.